Hello, my dear students, and welcome in the Indoor Environmental Control course. I am Associate Professor Kareem Galal.
This time I will continue to explain the heat science. The title of this lecture is Thermal Comfort. The thermal comfort is the main target in the indoor environmental control process, which spend a lot of money to be controlled. The human body continuously produces heat by its metabolic processes. The heat output of an average body is often taken as 100 W, but it can vary from about 70 W, in sleep, to over 700 W in heavy work or vigorous activity. The body's thermal balance can be expressed as follows, where M equals metabolic heat production, RD equals net radiation exchange, CV equals convection, including respiration, CD equals conduction, EV equals evaporation, including respiration. Delta S equals change in stored heat. A condition of equilibrium is that the sum delta S is zero, and such an equilibrium is a precondition of thermal comfort. However, comfort is defined as the condition of mind that expresses satisfaction with the thermal environment. It requires subjective evaluation. Oshry, 1997, this clearly embraces factors beyond the physical/physiological. The variables that affect heat dissipation from the body, and thus also thermal comfort, can be grouped into three sets as follows. Air temperature is the dominant environmental factor, as it determines convective heat dissipation. Air movement accelerates convection, but it also changes the skin and clothing surface heat transfer coefficient, reduces surface resistance, as well as increases evaporation from the skin, thus produces a physiological cooling effect. Subjective reactions to air movement are as follows. But under overheated conditions, air velocities up to 2 m/s may be welcome. Medium humidities, RH 30 to 65%, do not have much effect, but high humidities restrict evaporation from the skin and in respiration, thus curb the dissipation mechanism, whilst very low humidities lead to drying out of the mucous membranes, mouth, throat, as well as the skin, thus cause discomfort. Radiation exchange depends on the temperature of surrounding surfaces, measured by the MRT, or mean radiant temperature. This is the average temperature of the surrounding surface elements, each weighted by the solid angle it subtends at the measurement point. As thermal comfort is influenced by another three environmental variables, attempts have been made since the early 1900s to create a single-figure comfort index, which would express the combined effect of all four, or at least several, of these variables. Algi, 1953, introduced the Bioclimatic Chart, which has the RH on the horizontal and the dBT on the vertical axis, and the aerofoil shape in the middle is the comfort zone. Curves show how air movement can extend the upper limits, and lines below it show the extension by radiation. The latest comfort index, now generally accepted, is the ET*, ET star, or new effective temperature, and its standardized version, the SET. The ET*, constructed for 0.57 CLO and 1.25 MET, has been found to be valid for pairs of conditions such as, an increase in MET could be compensated for by a decrease in CLO. Thanks for following me, and I hope that I have explained the topic well.
This material is copyrighted. Associate Professor Kareem Galal 2021. All rights reserved.